Hello kids, in this video we are starting the first chapter of physics, motion. The topics that we will cover in this video: motion, rest, quantity, unit, scalar vector quantity, distance, displacement, speed, velocity, and we will take few graphs. Starting with the name of the chapter, motion. What do we understand by motion? Maybe the first term that comes to our mind when we think of the term motion, it might be movement. Yes, movement of a body, of an object from one place to another. Absolutely. And in day-to-day life, we see so many examples of objects which are in motion. Hands of clock are in continuous motion. So whenever there is motion, there is movement. So here we are going to look at different kinds of motion. Yes, we will be extensively studying motion in this chapter. Firstly, to define motion, we will say that whenever any object changes its position with respect to a fixed point or a reference point with respect to time, it is said to be motion. Right now when I am sitting here, I am at a certain distance from this whiteboard. Taking the whiteboard as the reference point or the fixed point. Now with respect to time, I notice my distance from the whiteboard does not change, it remains the same. Now my distance with respect to this fixed point or this reference point is not changing with respect to the change in time. We can say that I am at rest. But if I start to walk, my distance with respect to this fixed point will change with time. Now because my distance with respect to this fixed point is changing, we would say the object is at motion or the object is in motion. So what is motion? Whenever an object changes its position with respect to a fixed point or with respect to a reference point, with respect to time, the object is said to be in motion. And if the object does not change its position with respect to a fixed point, the object is at rest. So that is motion, rest. You should always understand that motion is a relative term. Motion is a relative term. Motion is not absolute, it is relative. An important statement, you should always understand what does it mean. Now I will just elaborate, I will try to explain the statement. Let's say A, B and C are three friends. A and B are going for a tour and C comes to drop A and B at the bus stop. A and B, they both board the bus and they are sitting together. C, who is outside the bus, can see both A and B. Now as the bus starts, C can view A and B in the moving bus. Now for C, are A and B in motion? Yes, absolutely. Because A and B both are sitting in a bus which is in motion. C is outside the bus. C could see the bus in motion. So for C, A and B who are also in the bus are in motion. But what if A asks B, am I in motion? A who is sitting besides B. For B, A is not in motion because with respect to B, A who is sitting besides him, the distance of A will not change. A is at a fixed distance from B. So if A would ask B, am I in motion? B would say, no, you are not in motion. But if A asks C, am I in motion? C, who is outside the bus and who can view A in the moving bus, for C, A is in motion. So the object is same. A is the object over here. For C, A is in motion, and for B, A is not in motion. Hence we say motion is a relative term. That is, here in this example, with respect to C, A is in motion. With respect to B, A is not in motion. We can take a similar example. If you remember Jadoo, koi mil gaya. Let's say Jadoo is in some other galaxy, and from that galaxy is viewing our Milky Way galaxy, and in that Milky Way galaxy he sees our solar system. In the solar system he sees planet Earth, and let's say from that galaxy he can view you on planet Earth. You are sitting at your place, staring at the monitor. For you, you are not at rest because you are at a fixed point. You are sitting on your chair right now maybe. But when Jadoo views you from some other galaxy, and Jadoo sees the planet Earth moving and you on planet Earth. Now because as planet Earth is revolving on its own axis, for Jadoo you are also in motion. You are the object. For you, you are not in motion. For someone who's on some other planet or some other galaxy and he views you, for him you are in motion. So the same object, but for different viewers, the perception is different. For one, that same object is at rest, and for the other, the same object could be in motion. Hence we say motion is a relative term. Moving on to the next topic, or next concept rather, a very important concept which I normally find students find it like students are not aware of the concept. It is very basic, you should very well know it. The term is quantity. Normally when we think of quantity, the thing that comes to our mind is amount of substance, quantity of something. It could be numbers, it could be in masses, 5 kg, 10 kg. But with respect to physics, quantity has an altogether different meaning. In physics, quantity is anything which can be measured. If you can measure anything, it is a quantity. Like, we can measure length, we can measure mass, we can measure time, we can measure density, we can measure temperature. So all these are quantities. Anything that you can measure is quantity. What is the distance of school from your home? You can measure that. What is the temperature outside right now? You can measure that. So anything which could be measured is a quantity. Yes? Now, you cannot measure how happy you are. That could not be measured. You could not quantify that. You could not measure it. Hence, it is not a quantity. Now, let's say length is a quantity. If you want to measure length, you can measure it in kilometer unit, you could measure it in meter unit, centimeter, and many more. So, the quantity is length, and you can measure length in kilometer, meter, centimeter. So, these are all units of distance. Same way mass. Mass could be measured in the units of kilogram, gram, milligram. Time could be measured in the units of hour, minutes, seconds. So all these are units. So quantity, anything that can be measured, and when you measure a quantity, you measure it in some particular value. The value in terms of which you are measuring that quantity is the unit. Yes. So that was quantity and unit. The next topic is scalar quantity and vector quantity. There are several quantities. Now when we closely examine the quantities, we notice some quantities have only magnitude. What is magnitude? Magnitude will be the numerical value. Let's say my house is 5 kilometers away from my office. So that 5 is the magnitude. X is 70 kgs. So that 70 is magnitude. You are 5 minutes late. So that 5 minutes is magnitude. So that numerical value, that number, using which we could compare two similar quantities, which is more, which is less. How do you compare them? You will compare them looking at the numbers. So that very value, that numerical value is your magnitude. Now, but there are certain quantities which require direction as well. Let's say I am applying a force on an object. Now, which direction the object will move? The direction the object will move will be in the direction of the force. Firstly, why will the object move? The object will move because of the amount of force, that is because of the magnitude of force. And in which direction it will move? It will move in the direction of the applied force. So there are some quantities which will have both magnitude as well as direction. Such quantities which require both magnitude as well as directions are called vector quantity. And those quantities which require only magnitude are called scalar quantity. In 9th physics, majority all the chapters, we will be studying several quantities. And when we study those quantities, we will simultaneously try to understand, we will try to classify the quantity, whether that quantity is scalar or vector. So what is a scalar quantity? Those quantities which is independent of direction or which does not require direction to define itself, which require only magnitude, are called scalar quantity. But those quantities which require both magnitude as well as direction are called vector quantities. So now let's study few quantities, starting with distance and displacement. For a common man, distance and displacement would mean the same. But physics very well differentiates between distance and displacement. In physics, distance and displacement has altogether two different meanings. Now let's try to understand it with an example. Let's say point A is Surat and point B is Mumbai. Now you want to travel from Surat to Mumbai. Surat to Mumbai, let's say we have this one route which is an expressway, and then we have the second route which is through the interiors of these towns. Let's say this distance is 300 kilometers and let's say this distance is 350 kilometers. Now X takes route 1 and Y travels through route 2. So if someone asks what is the distance travelled by X? So we will say X travelled 300 kilometers. And what is the distance travelled by Y? Y travelled 350 kilometers. So that is distance. So what is distance? Distance is the actual length of the total path covered. Now because X travelled through this path, the length of this path was 300 kilometers. So the distance travelled by X is 300 kilometers. On the contrary, Y takes an altogether different path. The length of this path was 350 kilometers. So the distance travelled by Y is 350. And I assume we all understand distance in the same manner. So this is nothing new to you. Now what is displacement? Displacement does not take the direction, the route into consideration. Displacement is the shortest distance between the initial and final point. Now initial point was Surat and final point is Mumbai. irrespective of which path you follow. The shortest distance is this particular direction. So for displacement, the direction is very important. To find displacement, we will take no other direction, we will stick to this direction. So the direction becomes very important. So if someone says, what is the displacement of A? So we will say the displacement of A is again 300 km. What is the displacement of Y? Sorry, displacement of X is 300 km and displacement of Y, though Y travelled a distance of 350 km, still its displacement would be 300 km. Why? Because displacement does not take the path into consideration. Displacement will always focus on the shortest path. Now the shortest path will have a fixed direction. So displacement takes that particular direction into consideration. Hence, irrespective of what path you follow, let's assume there is one more different path. If someone would have gone through this path and he would have travelled a distance of 400 km, still his or her displacement would be 300 km. Is that clear? Again, one thing if you notice, this was a straight path. So when an object is on a straight path, the distance and the displacement are same. But when an object takes a slightly convoluted path, the distance might increase. But displacement will always be fixed. Displacement will always be the shortest distance. So from this diagram, we can also infer one thing, that displacement can be equal to distance when if the object is in a fixed straight direction. But displacement can never exceed distance. You can follow a convoluted path. When you follow a convoluted path, the distance will increase. Hence, distance can exceed displacement, or distance would be equal to displacement, but distance will never be less than displacement. Yes? So, I suppose you could very well gauge the concept. So now distance can follow any direction, it is independent of direction, so we can say distance is a scalar quantity and displacement is a vector quantity. Now distance, displacement both are length, so their units would be unit of length. The unit of length, it could be measured in kilometer, meter, centimeter. But most important thing to keep in mind is, you should always bear in mind that distance, because it is independent of direction, it is a scalar quantity, and displacement, it requires both magnitude as well as direction. This 300 km, 350 km, what was that? That was magnitude. So distance also has magnitude, displacement also has magnitude. But distance is independent of direction. So we do not require direction to define distance, so it is a scalar quantity. But displacement has direction intact with it. It depends on the direction also. So it requires both magnitude as well as direction. Hence, displacement is a vector quantity. Now the SI unit stands for International System. The unit that we follow world over for distance and displacement is meter. So the SI unit of though kilometer, meter, centimeter, millimeter, all these are unit of distance. But the standard unit for distance and displacement is meter. Next, we will discuss the differentiation between distance and displacement. Examination point of view important. Firstly, you can define. How would you define? We will say distance is the total length of the actual path covered, and displacement is the shortest length between the initial and final point. Distance is a scalar quantity, displacement is a vector quantity. Distance is always positive. Displacement can be positive, can be negative, can be zero. I would explain why do we say or how do we say this point, important point. That is, distance is always positive, displacement can be positive, negative or even zero. Distance is always greater than or equal to displacement, displacement is always less than or equal to distance. Let's try to understand why are we saying that displacement can be positive, negative or zero. Let's understand this concept using a number line. Let's say A is at the origin. Let's take the right hand side to be positive and the left hand side to be negative. Now let's say suppose A starts from the origin, and A comes to point B. Now if A travels from A to B, that is from origin to B, what is the distance travelled? Let's say these units are in kilometers. So we will say the distance travelled is 2 kilometers. What is the displacement? The displacement is also 2 kilometers. Now from B, let's say A comes to C. So now what is the distance travelled? You will say 4 kilometers. And what is the displacement? Again 4 kilometers. Now suppose from C, A comes to D. A to B, B to C, C to D. So now what is the distance travelled? So you will say the distance travelled, A to C was 4 kilometers, C to D is another 3 kilometers, so the distance travelled is 7 kilometers. What is the displacement? Now displacement is the shortest distance between the initial and final point. Where did you start from? We started from the origin, that is at A. Where are you now? You are at D. So what is the shortest distance between A and D? The shortest distance between A and D is 1. So our displacement is only 1 kilometer. Now suppose from D you came back to A again. So now what is the distance travelled? So we travelled one more, so our distance will become 7 plus 1, 8. But our displacement, we started from the origin, now we are back to the origin. So the distance between the initial and final point is 0. Why? Because you are back to the place from where you started. Hence displacement is 0. That is why we say displacement can be 0, but is distance 0? No. You went 4 kilometers right and you came back 4 kilometers. So distance is 4 plus 4 8. Now suppose let's say from A you came to E. So now what is the distance travelled? So we can say distance travelled A to C was 4. C to origin, that is A again 4. Then from A we went 2 kilometers to the left. Now because distance does not take direction into consideration, so for distance it is always positive. So it is 10 kilometers. But displacement would be, you first went A to C to the right 4, then C to A to the left is negative, and then from A to E again to the left. So your displacement is minus 2 kilometers. Hence we say displacement can be negative. Is that clear? We will end this video here. We will take the other topic in the next video. Thank you.